Hey my friends, welcome to Joey's Tech. You will learn the Radix Sort algorithm in this video from Joey. I'll tell you how the Radix Sort algorithm works, then we'll implement it in a Java program, and finally I'll tell you its time complexity. Before we start, make sure you like this video and subscribe to Joey's Tech if haven't already, because that way you will get notified when I release videos like such in the future. Let's know a little bit about Radix Sort before we see how it works. Quicksort, Mudsort, Heap Sort can't do better than nlogn when it comes to time complexity. If you talk about counting sort, then it is a linear time sorting algorithm that sorts in O(n plus k) time, where k is the range of input. So what if the elements in the array are in the range of 1 to n square? We can't use counting sort solely then, because it is going to sort the array in big O squared time. So what's the solution if we want to sort such an array? It's Radix Sort. So how does a Radix Sort work? Radix Sort does digit by digit comparison by starting from the least significant digit to the most significant digit. It groups the individual digits of the same place value. Now, if you remember the phrase place value with Radix Sort, you will never forget this algorithm. Important thing to note is that Radix Sort uses counting sort algorithm as an intermediate sorting algorithm to perform sorting at individual digits level, which is why you should watch the video that I have made explaining the counting sort algorithm. You will find the link in the description box of this video, or you can simply watch it by clicking on the I button. Let's now start understanding how the Radix Sort algorithm works. This is our problem array that we are going to sort using the Radix Sort algorithm. From this array, we are going to first pick out the maximum element. So what's the maximum element of this array? It's 787. Now we are going to find out how many digits does 787 have, or the maximum element of this array have. So 787 has 3 digits. Okay, so we need to perform sorting 3 times on the entire array as part of Radix Sort algorithm up to the hundreds place. So we need to go through each significant place one by one. We will use the counting sort algorithm to sort the digits at each significant place. However, you can use any stable sorting technique to sort them. So this is the right setup to perform the sorting of the last digit of every element. The array contains the last digit or ones place of every number written above their respective cells, and the number beneath the cells of the array represents the indexes of the items. Since we are using the counting sort algorithm, hence we need to create an auxiliary array. Now its size will be 1 plus the max element of this array. The max element of this array comes out as 7. So the size of the aux array will be 8. Now let's quickly store the count of each element of this array into the aux array. So first I'm going to fill this aux array with zeros. Okay. Now the first element here is 2. So at index 2, I increment the value by 1. So the value here becomes 1. Then I have 1 as the second element. So at index 1, I increment the value by 1 again, and this value also becomes 1. The third element is 5. So the value at index 5 also gets incremented by 1 and it becomes 1. The fourth element of this array is 2. So at index 2, I am going to increment the value, which is 1 already, by 1. So this value becomes 2. This means that 2 is present 2 times in this array. Now the fifth element is 1. So at index 1, I am going to increment the value by 1 again. So it becomes 2. At index 5, I have 7. So I'm going to go at index 7 of the temp array and increment the value stored by 1. So this becomes 1 again. At index 6, I have 7 again. So I go to index 7 in the temp array and increment the value stored by 1. So this becomes 2. This means that 7 is present 2 times in the input array. Now we are going to modify the temporary array, the temporary count array, to store the cumulative sum. Each element will store the sum of the previous counts. So we are going to start from this element at index 1. 2 plus 0 is going to give us 0. So no change over here. Then we are going to move to this element. Over here we have 2. 2 plus 2 is 4. So I'm going to put 4 over here. Then at index 3 we have 0. So 0 plus 4 is going to give us 4. So let me populate 4 over here. At index 4 we have 0 again. 0 plus 4 gives us 4. So I'm going to populate 4 over here. At index 5 we have 1. 1 plus 4 gives us 5. So let me populate 5 over here. Over here it will be 5 populated at index 6, and over here 2 plus 5 is going to give me 7. So 7 will be populated over here at index 7 in the temporary count array. So the array has now been modified to provide us the position of each element in the output sequence. So the next step is going to sort the numbers based on the last digit. In counting sort, we start from the left and go towards the right. But in this case, we are going to start from the right and go towards the left. Why? Because these repeating digits, they represent different numbers and we want to place them correctly in order to sort them properly. So we are going to start from here. The value here is 7. So we go to index 7. Here we find 7. We subtract 1 from it. So we get 6. We update 6 over here. And at index 6, we place 7 and the corresponding number, which is 787. Then we go to the next element. Over here we have 7. We go to index 7. We find 6 over here. We subtract 1 from it. We get 5. We update this item with 5. At index 5 in the output array, we place 7 and the corresponding number, which is 47. Then we go to the next element, which is 1. So we go to index 1. We find 2 over here. We subtract 1 from it. We get 1. We update this item over here with 1. And at index 1, we place 1 and the corresponding number, which is 1. We go to the next element. Here we have 2. We go to index 2. We find 4 over here. We subtract 1 from it. We get 3. We update 3 over here. And at index 3, we place 2 and the corresponding number, which is 22. Okay. Then the next element is 5. So we go to index 5. We find 5 over here. We subtract 1 from it. We get 4. We update this item with 4. And at index 4, we place 5 and the corresponding number, which is 565. Then the second last element is 1. So we go to index 1. Here we find 1. We subtract 1 from it. We get 0. We update 0 over here. And at 0, we place 1 along with the corresponding number, which is 431. And the last element is 2. So we go to index 2, we find 3 over here, we subtract 1 from it. So we update this item with 2 and at index 2 we place 2 and the corresponding number, which is 122. Alright. So this array is sorted using counting sort algorithm based on the last digits. That means ones place. Okay. Now we are going to sort this intermediate output array based on the tens digit. That means the middle digit. So this is going to be our input array, and you can see I have placed the middle digits of these numbers over here. Okay. Now we are going to sort this array based on the middle digit or the tens place. Okay. So we are going to first create a temp count array as we do in counting sort algorithm. The maximum element from this array comes out as 8. So we are going to create a temporary count array of size 9. Now let me quickly fill this array with the counts of the respective elements from this array. Before that, I'm going to fill this array with zeros. Now let me start from the first element. We have 3 as the first element. So we go to index 3. Here we increment the value by 1. So this value becomes 1. The next element is 0. So we go to index 0. Here we have the value 0. We increment it by 1. So we get 1 over here. Over here we have 2, which is the third element. So we go to index 2 and we increment the value by 1. So we get 1 over here. The fourth element is 2. So we go to index 2. Here we have 1. We increment it by 1. So we get 2. And then the fifth element is 6. So we go to index 6. Where we have 0, we increment it by 1, so the value here becomes 1. Over here we have 4, so we go to index 4. Here we have 0, we increment it by 1, so let me place 1 over here. And the last element is 8, so we go to index 8. Here the value is 0, we increment it by 1, so the value here becomes 1. Okay, so the temporary count array now holds the counts of the respective elements of this array. Now let's modify the temporary count array to store the cumulative sum as we did over here. So we are going to start from this element. The value that this index is going to get will be 0 plus 1. So it will be 1. Over here it will be 2 plus 1. So it will be 3. Over here it will be 4. Then the value here is going to be 4 plus 1, which is 5. So let me place 5. Over here it will be 5. Over here it will be 6. In this cell of the array it will be 6, and in the last cell of the temporary count array the value will be the addition of 6 and 1, so it will become 7. Alright, now let's perform the final step, which is going to sort this array based on the tens digit. So we are going to start from this element, which is 8. So we go to index 8. Here we find 7. We subtract 1 from it. We get 6. So we update 6 over here. And at index 6, we place 8 and the corresponding number, which is 787. Then the second element from the right is 4. So we go to index 4. We find 5 over here. We subtract 1 from it. We get 4. So we update this cell with 4. And at index 4, we place 4 and the corresponding number, which is 47. Then the third element from the right is 6. So we go to index 6. Here we find 6. We subtract 1 from it. We get 5. We update this cell with 5. And at index 5, we place 6 and the corresponding number, which is 565. The fourth element from the right is 2. So we go to index 2. Here we find 3. We subtract 1 from it. We get 2. So we update this cell with 2, and at index 2 we place 2 and the corresponding number, which is 0 to 2. Okay, the next element is 2. So we go to index 2 again. Here we find 2. We subtract 1 from it. So we get 1. We update this cell with 1. And at index 1 we place 2 and the corresponding number, which is 1 to 2. Okay, now the next element is 0. So we go to index 0. Here we find 1. We subtract 1 from it. So we get 0. We update this cell with 0. And at index 0, we place 0 and the corresponding number, which is 1. Alright. Now the final element is 3. So we go to index 3. Here we find 4. We subtract 1 from it. We get 3. So at index 3, we place 3 and the corresponding number, which is 431. Alright. And there you go. The array is sorted based on the tens digit. So first, this array was sorted based on ones place, and then it got sorted based on the tens place. Alright, or the middle digit. Now this is an intermediate output array that we are going to sort based on hundreds place, or the leftmost digit. Now the counting sort algorithm is going to run for the third time, and this is going to be the input array. Technically, the input array is going to be the digits at hundreds place of these numbers. Alright, so the maximum element from this array is 7. So we are going to create a temporary count array of size 8, and let me fill this array with zeros. Now we are going to store the count of each of these elements in this array. So we are going to start from this element. Here we have 0. So at index 0, we are going to increment the value stored, which is 0. We increment it by 1, we get 1. So we update this cell with 1. The next element is 1. So we go to index 1. Here we increment the value by 1. So this value becomes 1. The next element is again 0. So we go to index 0. Here we have 1 already. We increment it by 1. It becomes 2. The fourth element is 4. So we go to index 4. Here the value is 0. We increment it by 1. We get 1. And we get 0 the third time. So we go to index 0. Here we have 2. We increment it by 1. We get 3. And the second last element is 5. So we go to index 5. Here the value becomes 1. 0 plus 1 is 1. And finally we have 7. So at index 7 we have value as 0. We increment it by 1. So this cell will hold 1 as its value. Now let's modify this temporary count array to store the cumulative sum. So we are going to start from this cell. We are going to add 1 and 3. So that will give us 4. So we update this cell with 4. We move to this cell. Here we have 0. 0 plus 4. We update 4 over here. Then in the next cell, we are going to update 4 because 0 plus 4 is 4. In the next cell, it will be the addition of 1 and 4. So it will be 5. Over here, it will be the addition of 5 and 1. So it will be 6. Over here, it will be the addition of 0 and 6. So this will be 6. And the last cell is going to hold the addition of 1 and 6, which is 7. So I place 7 over here. Alright, now let's perform the final step in which we are going to sort this array by hundreds place. And basically this will be the final sorting step that is going to sort this entire array in ascending order. So we are going to start from the rightmost cell and move towards the left. So the first cell when we start from the right is 7. So we go to index 7. Here we find 7. We subtract 1 from it, we get 6. So we update the value here with 6. And at index 6, we place 7 and the corresponding number, which is 787. Then we move to the second last element, which is the second element from the right hand side. Here we have 5. So we go to index 5. Here we find 6. We subtract 1 from it, we get 5. We update this cell with 5. And at index 5, we place 5 and the corresponding number, which is 565. Then we go over here, we get 0. Now we go to index 0. Here we find 3. So we subtract 1 from it, we get 2. So we update 2 over here. And at index 2, we place 0 and the corresponding number, which is 47. Let me place 47 like this now. And the next element is 4. So we go to index 4. Here we find 5, we subtract 1 from it, we get 4. So we update this cell with 4. And at index 4, I place 4 and the corresponding number, which is 431. The next element is again 0. So we go to index 0. Here we find 2. We subtract 1 from it. So we get 1, which we update over here. And at index 1, we place 0 and the corresponding number, which is 22. Okay. Then the next element is 1. So we go to index 1. Here we find 4. We subtract 1 from it. We update this cell with 3. And at index 3, we place 1 and the corresponding number, which is 122. And the final element is 0. So we go to 0th index. Here we find 1. We subtract 1 from it. We get 0. We update this cell with 0. And at index 0, we place 0 and the corresponding number, which is 1. And there you go, the array is sorted. Now in this case, especially if I had started from the leftmost element and had moved towards the rightmost element, I would have placed this one over here at the third cell, which would have been wrong. This is why it's very important that we start from the right hand side and move towards the left hand side. Now let's implement the Radix Sort algorithm in a Java program, because that is going to teach you how to write the Radix Sort algorithm in the first place. Here I am in my IntelliJ IDE where I have created this class Radix Sort, in which I'm going to create first the main function, in which I'm going to first declare and initialize an array. So let me call it data. And it's going to contain a few elements, which will be 122, 431, 565, 22, 1, 47, 787. Now let me create the object of this class, which I'm going to use to call the Radix Sort function. So let me create the object. I'm going to call it rs. Alright, and I'm going to use this rs object to call the Radix Sort function. And the parameters that I'm going to pass to this function will be the array. So it will be data, and the size of the array or the length of the array. So it will be data dot length. I haven't created the function yet. That's why it's highlighted in red. I would also like to print the array before calling the Radix Sort function and after calling the Radix Sort function to show that the program sorts the array. So over here, let me quickly write the code to print the array. So it will be system.out.println before sorting. Then I'm going to write system.out.println again, and within brackets I'll write arrays.toString, and within this bracket I'm going to print data, and I'm going to copy these two lines of code and paste it after the call to the Radix Sort function. Over here I'm going to make a small change. I'll write after sort. Okay, so this line of code is going to print the problem array, and this line of code is going to print the sorted version of the array, sorted using the Radix Sort algorithm. Now let's create the Radix Sort function. So it will be void Radix Sort, and it's going to accept an array as the first parameter, and it's going to accept the size of the array as the second parameter. All right, the first thing that we did when we started working on the Radix Sort algorithm was to find the maximum element from this problem array. So let's write the code for that. So it will be int max equals to array element at index 0, and then I'm going to start a for loop. It will start from index 1 and it's going to run for the length of the array. So I will be less than size I plus plus, and within for loop it will be an if condition. If max is less than array at index I, then max will be assigned the element at index I of the array. Okay, so this is the code to get the maximum element from this array. Now the next step will be to apply the counting sort algorithm on this array. The counting sort algorithm will be applied 3 times because there are 3 digits in the maximum element. Let's write the code for that. We are going to write a for loop that is going to start from 1. P represents place over here. Why P is equal to 1? Because we'll be sorting the elements of the array first based on 1's place. All right. Now the terminating condition of this for loop is going to be max divided by P greater than 0, and the final condition is going to be P multiplied equals to 10. So let's understand this. This loop is going to run till max divided by P is 0. So the max over here is going to come out as 787. 787 divided by 1 is going to give us 787, which is greater than 0. So the loop is going to run, and that will be the first iteration. In the second iteration, P will become 10. So it will be 787 divided by 10. The quotient will be 78. It's again going to be greater than 0. So the loop is going to run, and that will be the second iteration. In the third iteration, the value of P will become 100. So max by P will be 787 by 100. The quotient is going to come out as 7. The value is greater than 0. So the loop is going to run, and that will be the third iteration. However, in fourth iteration, the value of P is going to become 1000. 787 by 1000 is going to yield 0, and 0 is not greater than 0, so the loop is not going to run, it is going to terminate. So now you understand the loop. All right, and thus the counting sort algorithm will be applied 3 times. So let's make a call to the counting sort function. So it will be counting sort, and it's going to accept obviously array as the first parameter. The second parameter will be the size of the array, so it will be size, and the third parameter is going to be P, the place. That is important, right? Now let's create the counting sort function. It will be void counting sort, and obviously it's going to accept the array as the first parameter. Then it's going to accept its size, and finally it's going to accept the place based on which it needs to sort the elements. Okay, the first step will be to create the output array that will be of the same size as the input array. Okay, so I'm going to write the code for that. It will be int output square brackets equals to new int, and within square brackets I'm going to write size. Okay, now the next step will be to create the temporary count array. Now since we'll be applying the counting sort algorithm on individual digits that we are going to calculate based on ones, tens and hundreds place, the individual digits will always fall in the range of 0 to 9. That means the size of the temporary count array will never exceed 10. So why not create a temporary count array of size 10 and get it over with? So let's write the code for that. It will be int temp count within square brackets equals to new int, and within square brackets let the size be 10. Okay, now we are going to write the code to fill the temporary count array with zeros. I'm going to stick to writing Java code for that, so it will be arrays dot fill, within brackets it will be the array name, which is temp count comma 0. Alright, this is going to fill the entire array with zeros. Alright, now we are going to write the code to store the count of distinct elements of this array into the temporary count array. So I'm going to be writing a for loop. It will be for int I equals to 0, and it's going to run for the length of the array, input array. So it will be I less than size I increment operator, and we will be storing the count in the temporary count array. So it will be temp count, and within brackets what expression should we write? That expression, that code expression should calculate these digits. That means the digits at ones place, the digits at tens place, and the digits at hundreds place on the go. So it will be within brackets array at index I divided by the place variable modulo operator 10, and outside we are going to write the increment operator. So let's take this number. For example, we have 122. In the first iteration the value of place will be 1. 122 divided by 1 is going to yield the quotient as 122. When 122 will be divided by 10, the modulo operator, the remainder is going to come out as 2. Alright, so the last digit is correctly calculated, and in the temp count array at index 2 the value will be incremented by 1. Okay, in the second iteration the value of the place variable is going to become 10. So let's consider this number. For example, 431 divided by 10 is going to yield the quotient as 43. When 43 is further divided by 10, the remainder is going to come out as 3. Hence the tens digit gets correctly calculated by this code expression. Okay, now we will modify the temporary count array to store the cumulative count. So the code for that will be another for loop, and this time it's going to start from 1. It's going to run till index 9. So it will be I less than 10 I increment operator, and within for loop we are going to write temp count at index I equals to temp count at index I plus temp count at index I minus 1. Alright, this is going to modify the temp count array to store the cumulative count. Now we'll write the final step of the program, final step of the counting sort algorithm, in which we are going to place the elements in correct order in the sorted array. So it will again be a for loop that's going to start from the rightmost element, because that's what we have been doing, right? So it will be int I equals to size minus 1, and it's going to run till the first element, that means till index 0. So it will be I greater than equals to 0 I decrement operator. Alright, since I have to place the elements in the output array, so it will be output, and within square brackets we'll have to write some code expression. What will that be? So during our algorithm study we picked an element from here, looked it up in the temporary count array to find the value. So this expression over here is going to do the job for us. So I'm going to copy it and paste it over here. Once we got the value, we subtracted 1 from it to get the index of the output array. Okay, so I'm going to subtract 1 from this expression, and at that index we placed the element from the input array. So here we are going to place directly the number rather than the individual digit. So it will be array within brackets I. Okay. And of course we updated the corresponding cell of the temporary count array with the decremented value, with the value that we got by subtracting 1 from it. Okay, so it will be this expression. I'm going to copy it, paste it over here, and the decrement operator. Alright, the final step will be to copy the elements of the output array into the input array. So it will again be a for loop. It's going to start from 0. It's going to run for the length of the output array, and within the body of the for loop it will be array, which is our input array, at index I equals to output array at index I. This will do the job for us. Alright, I think we are done. Now let's run the program and check the output, whether this Java program that implements the Radix sort algorithm is able to sort this array or not. And there you go. The array before sorting is our problem array. And look at this. This is the sorted version of the problem array, sorted in ascending order using the Radix sort algorithm. That means the program, the Java program implementing the Radix sort algorithm is working pretty fine. By the way, you can find the GitHub link to this Java program in the description box of this video. You can surely check it out. Let's now learn the time complexity of the Radix sort algorithm. So the best case, average case, and the worst case time complexity of Radix sort algorithm is big O n plus k, and when it uses counting sort as the intermediate sorting technique, then the time complexity becomes this, where d is the number of digits. With this, we have come to the end of this video. I hope you enjoyed learning the Radix sort algorithm from Joey's Tech. Do watch all the videos of Joey's Tech on other important sorting algorithms such as merge sort, quick sort, etc. And I'll see you in the next video of Joey's Tech. And only for this video, goodbye and take very good care of yourself.